first problem here, we have x squared minus 2x minus 35 over x squared minus 9x plus 14. And our thought process here has to be when you see x squared, x in a number, a factor. X minus 7, x plus 5. X minus 7, x minus 2. Okay? And something's probably going to cancel. In this case, x minus 7 cancels, and I'm left with x plus 5 over x minus 2. When we multiply, we've got to factor all 4 sections. And remember, you simplify vertically and diagonally, and you multiply horizontally. So here I can take a 6 out, and I'm left with x minus 3. X plus 8, x minus 8, and we factor. Here we have x minus 8, x plus 6. And down here we have x minus 3 and x plus 2. Okay? There's nothing vertically to cancel. But x minus 3 and x minus 3 cancels, x minus 8 and x minus 8 cancels. And we're left with 6 times x plus 6 over x plus 8, x plus 2. Here's our answer. Division. My advice is this. Before you do anything, flip the second fraction. I wouldn't factor anything. I would literally copy the problem over again, exactly as is. And now, I take a 7 out, and I'm left with x minus 4 over 14x. X has nothing to do with that, but x squared minus 16, x minus 4, x plus 4. Diagonal, diagonal. That becomes 1, this becomes 2, and I multiply across. 1 times x is x. 2x times x plus 4. Here's my answer. Now the next one is pretty straightforward. If you have a common denominator, addition is pretty easy. You add the numerator. This becomes 33 over 11x, which reduces to 3 over x. When I get something like this, this is pretty basic in the sense that whatever is in the parentheses, you just plug in for x. So p of negative 5 is going to equal 8 minus a negative 5. P of negative 5 equals 13. There's your answer. Okay, whatever is in that parenthesis is what you're going to plug in for x. Number 6, same deal. R of x equals x cubed minus 5x plus 7. R of 2a equals 2a cubed minus 5 times 2a plus 7. 2a cubed is 8a cubed. 5 times 2a is, or negative 5 times 2a is negative 10a. And then we just add the 7 on. And there's our answer. All right, so for the problem, f of x equals 4x to the 4th minus 7x to the 5th plus 3x to the 6th. The leading coefficient is 3. And the degree is 6. The highest exponent represents the degree. The leading coefficient is the coefficient in front of the variable with the highest exponent. We ask for the maximum and the minimum here. Now, the maximum here, okay, is actually, let me erase that and draw a more accurate graph compared to what's on the paper. Sorry. So let's do this, and I believe the graph looks something like this. Where this is 0.20, this is 0.02, and this point here is 0 or 1.4, and this is -1.0. Now, if they're asking for max and min here, the absolute max is infinity, and the minimum is -infinity. If on the test they're looking for a local max or a local min here would be -1.0, and a local max would be 1.4. Okay. So now, how many real zeros? How many real zeros here? Wherever we're crossing the x-axis, the answer is simply 4. That's how you get your real zeros. We have the normal distribution over the bell curve. First thing I'm going to do is I'm going to write out my numbers. 82, 79, 76, 88, 91, 94. Okay. 34%, 34%, 13.5, 13.5, 2.35, 2.35, and then the extremes of 0.15 and 0.15 on either end. If I want between 82 and 91, 34 and 34 is 68, 68 and 13.5 is 81.5%. That's your first one. Between 76 and 94, you're talking about 99, 0.3%. Yikes. I'm just saying anything. I'm sorry, 99.7%. We really don't need a calculator for that. We're just adding that up. Greater than 88. Well, this is 2.5 and this is 13.5. So greater than 88 is 16%. Okay. And then what are the probability that we're lower than 79? So lower than 79%, you're talking about 2.5% chance there. So these are your 4 answers to the 4 questions on the normal distribution. Notice you don't need to use a calculator for these. You won't have to on the test as well. It's just a straightforward empirical rule. The next one says this: 15 times 0.8 raised to the x power. Is it growth or decay? This is an example of decay. When the value is less than 1, you're dealing with decay. Just to show you, this would be an example of exponential. Growth. Okay, and I should have put, actually right here, exponential decay, not just decay. So whenever that value is less than 1, right in here, you're talking about exponential decay. Whenever this value is greater than 1, you're talking about exponential growth. Okay? If the population of South Brunswick is currently at 50,000, that's my initial population. If the population decreases at a rate of 9%, it's 100% minus 9%. That's 0.91. How many people live in South Brunswick in X years? The time is always going to be the exponent. And that's it. On the test, you just have to write the equation out. You're not even going to have to figure out how long it's going to be. You're just writing the equation. Converting 9 squared equals 81 to a log. Remember, it's base equals whatever the base is raised to gives me this number right here. Okay? The base raised to this number gives me this. It almost kind of goes in a circle. 9 squared equals 81. That's how you convert it to logarithmic form. For 19, 3 to the 2x plus 4 is greater than 9. Whenever we have variables in the exponents, we've got to get to the same base. 3 to the 2x plus 4 is greater than 3 squared. So now I need to set 2x plus 4 greater than 2. If it were equal, we just set the exponents equal. Since it's an inequality, we just put the inequality. 2x is greater than negative 2, and my x is greater than negative 1. As long as my x is greater than negative 1, this will be bigger than this. Log 4x equals 3. As we said before, it's 4 raised to the third equals x, and 64 equals x. When you have the same bases, you can set these two equal. 12x equals 72 and x equals 6. 5 to the 3x minus 5 equals 25 to the 4x plus 3. When we get to here, we've got to have similar bases. So I'm going to change that 25 to a 5 squared. And now I'm raising a power to a power. So 3x minus 5 equals 8x plus 6. We subtract 3x, we get 5x. We subtract 6, we get negative 11. And negative 11 over 5 equals x. And our final problem, log x, 27 equals 3, is x cubed equals 27. What number cubed gives you 27? That answer is 3.